He's asking us to get not the variance, the one we just obtained, but to get the standard deviation. Okay, so let's get the standard deviation. Standard deviation. It says the square root of the variance. You have the square root of 5.84% squared, and you get 2 points.
2.413.
2.42.
417.
So 2.42%.
Yes.
Okay, so you get 2.42% to be the standard deviation. That's for y. Okay, can you do for z? The same process. You can attempt z, isn't it?
Yes.
Okay, so let me give you 5 minutes. You attempt z. The same process, and you get a standard deviation now for z. Okay, that's for y. Let's do for z. Same process. So the next measure of risk. Number 3, you can use coefficient of covariance. Let's use covariance. The use of covariance. Now, covariance is just like variance, as the name suggests, covariance, okay? And now there are two assets you want to assess. How do the return of those two assets move together? If, for example, we have X and Y, like we have here Y and Z, we have Z, Y and Z, okay? Now you want to evaluate, okay? If the return of Y are increasing, now how does the return of Z behave? Okay, as the return of Z decrease or increase in whatever way, how does the return of Y behave? Okay, that's what you want to evaluate. That's what you want to assess. Okay, now the measure you can use to evaluate how the return of the two assets, okay, move together, either increase, decrease, or whatever, is referred to as the covariance. Okay, is referred to as the covariance. Okay, so it's a measure of. Let me just put it down. It is a measure that evaluates how the returns of two assets move together, or how they behave. Okay, it's a measure that evaluates how the return of two assets move together. Okay, it's given us. No, that's not sigma. But covariance, assume that you have two assets, covariance, let me just call it present as COV, covariance of asset A and asset B, or X and Y, is given us. Now, if we need to check if is a population, let me begin by having the population. So here, if it is a population, then the covariance of A and B will be given us the return of A minus the mean return of A. We multiply by the deviation of the return of asset B, minus the mean return of asset B. Okay, from the first set outcome all the way to the last set of outcome, I is equal to 1 to the nth outcome. Since it's a population, we divide by n. It's just like, as we are seeing, just like the use of the variance. Okay. Okay, that's A. What if we did an example? Covariance of A towards B. Of course, I know you know the answer, but in a way, equal to sum of deviation from A. Sorry, this is A, not B. Okay, from the first outcome all the way to the nth outcome, we divide by n minus 1 since it's a sample. Okay. In case dealing with the case of probability distribution, to be equal to covariance of return of A towards return of B will be given as I is equal to 1 all the way to the other outcome. The deviation of return of A from the mean multiplied by deviation of return of set B from the mean and probability. We add here probability. Okay, probability we multiply, so the summation from the first outcome all the way to the nth covariance of A towards B. And that's how therefore we get therefore the covariance of the assets. Okay, we want to determine, okay, what's the general behavior. Okay, the idea here you want to tell is the general behavior, okay, of how the return of the two in quote influence each other, not in quote influence each other. If return of A is increasing, what is happening to the return of B? Okay, if return of B is decreasing, what's happening to the return of A? Okay, how do the return of the two assets move together? Okay, that's referred to as the covariance. Okay, this is referred to as the covariance. Clear?
Clear.
Okay, now assume this question that we have done right now. Okay, this the November 2019 question. Assume that one of the requirement the exam is asking you to get the covariance of return of Y towards Z. Okay, it's not given, not asked here, but assume that the examiner is asking you to get that to establish what the covariance between Y and Z. Okay, in that case, don't forget the data set we are able to in this question is probability distribution. Okay, don't forget the way the examiner has given us is probability distribution. Therefore, if you want to get covariance, okay, this is November 2019, same question, question 3B. Okay, assume that one of the requirements there is to get the covariance between Y and Z, Of course, we need to get, so you can have probability. So it's just like an extension of the table that you already drawn, okay, from, give me a second. Okay, so probability 0.1, 0.2, 0.35, all fit the last one. Then the return, right now, okay, you may want to repeat the return. We have already done the mean, okay? So I can just have here probability, return of A, mean return of A, multiplied by another column here, return of B, mean return of asset B. Okay, probability of asset A, I go the probability 0.1, does not matter, so 0.1. So the return of A for the first set of outcome at the 0.1 probability is 10. The mean was 10.4. The return of B for the probability 0.1 is 8 minus the mean return of B. What was the mean return of B?
8.7.
8.7.
8.7. Okay, the next set of outcome is 0.2 probability times the return for Y is 12 minus the mean 10.4. The return for Z at that point is 10 minus 8.7. Okay, 0.35. The return is 8 minus mean return 10.4. The return for Z at that point is 7 minus the mean return 8.7, all the way until the last one, 0.05, 0.15, 0.15, and you get the sum here. The sum will give us the covariance of y, return of y towards z. And what do you get?
We're calculating.
$4.02
Yes.
percent squared. Okay, someone to collect the answer. Now, what it means therefore is that, don't forget, as you can see, this is just like variance, it is percent squared. So therefore, to make sense out of the figure, it's a bit tricky. But since it's a positive, what does it mean? It means therefore that if the return of y are increasing, then the return of z also increasing. If the return of z are decreasing, the return of y are also decreasing. Okay, but to what extent you can't be able to tell for now. Okay, but to just show you the nature of relationship between the return of y and the return of z. Okay, this should not to be y and z, not a and b. This return of y, z, z. Okay, anyway. So essentially, that's the usefulness of the covariance. Okay, but that is, as you can see, it is a bit restricted. Okay, it does not tell you to what extent. Okay, it is to what extent does the return of y increase by what value? If a increased by 2%, what happens to b? Okay, just tell you that it will be increasing by how much. It does not tell you. That's why we need another better measure of how the two returns, the return of the two assets, okay, are going to behave. Clear to all of you? Anyone who is stuck? Okay, so no one is stuck. Therefore, the next measure, which will make sense to the figures we have just calculated, is the use of, so the fourth is what that. Yes, the covariance. So fourth. Number 4 is the use of coefficient of variation. Coefficient of variation. As the name is suggesting, we want to put a coefficient to the variation. Okay. Now we want to scale to ensure that the 4.02% squared, okay, we have obtained from the data we have analyzed, okay, is that those figures make sense now. Okay, those figures make sense. Okay. Actually, what we want to scale down, okay, the coefficient to scale down the covariance between -1 and +1. Okay, we want to scale down between positive the covariance between +1 and -1. Okay, called the use of coefficient of variation. Okay, now coefficient of variation. Okay, it measures. Let me just put it measures the strength. The strength of the relationship. The strength of the relationship between the returns of two assets. Okay, so you simply want to put numbers, scale it down, so that you can be able to evaluate. Okay, how strong is the relationship between these two values, the returns of y and z. Okay, you see what how to get to know the strength of that of the movement between the return of y and the return of z. Okay, how do the two returns move together? Okay, how the two we want to know to measure the strength of that movement. Okay, the covariance simply measure the movement. Okay, knows the strength of the movement. Okay, now it's given us. Okay, it's given us in the sake of coefficient of variation. What's able? Not sure what this symbol is called. Okay, it's not the exponential. I'm not sure how the term is used. Between asset A and asset B, okay, is equal to covariance between asset A and asset B divided by the product of their standard deviation. So standard deviation of A, standard deviation of B. So we get the coefficient of variation between asset A and asset B. Is we want to put, as I mentioned, we want to scale down, okay, the covariance. As I mentioned, covariance may not make sense on its own. Okay, only the only sense you can make it out it is whether is the figure positive or negative. Okay, if positive, and with the return again, if the return of A is increasing, the return of B also be increasing. If the return of A is decreasing, the return of B also be decreasing because it is positive. Okay, if it is negative, if the covariance was a negative figure, and therefore the return, if the return of A are increasing, then the return of B move in the opposite direction. So if A is increasing, B is decreasing. If B is increasing, then A is decreasing. So they move in opposite direction. But to assess to what extent the strength of that relationship, you can't unless you're able to compute the coefficient of variation. Okay. Now, if we get a positive one, if the coefficient of variation is positive 1, this is what referred to as perfect positive correlation. Perfect positive correlation. Now, what does it mean? It would mean if return of A, if return of A increase by a unit can be percent, okay, what I want to use by a unit, and then return of B increase because it's positive, increase by the unit. If there's a percent, if the A increased by 10%, then B increased by the same percent, 10%. Okay. If we get 0, if it's at a 0, it is called no correlation. There's no correlation between the return of A and the return of B. Okay. Therefore, if A increase, then there's no, you can't be able to tell how B is going to behave based on how A is behaving, in short. Okay, you can't tell if it's going to be a 0. If we get a negative 1, if we get a negative 1, they call perfect negative correlation. Perfect negative correlation. Okay, now what does it mean? If return of A increase by a unit, then return of B decrease by the unit. Okay, that's what a negative 1 correlation will mean. Okay, if A increase by 10%, then B decrease by 10%. Okay, for the case of negative 1. Okay, clear?
Clear.
Okay, now I want you to interpret. I hope it's clear because I want to give you you to interpret for me. If we have the correlation between A and B to be equal to negative 0.5, what does it mean? If this is just as an example, so just to see whether you understood. If the coefficient correlation between A and B is negative 0.5, what does it mean? I'm going to give you an example.
I would say it means a one unit increase in A results to a 0.5 decrease in B.
Okay, so I want to put figure. So if A increased by 10%, what happens to B?
B decreases by 5%.
By 5%.
Yes.
Yes.
By 10.
It's by 5%. Don't forget this 0.5. It's half by 5%. I agree with that. Now, there's another way of trying to interpret that. Which the other way is the other way? That's the perfect way of trying to interpret that. If A increased by 10%, then B decreased by 5%. How else can you interpret 0.5? You can use another example. Okay. I thought it was that easy. You've understood the concept in and out.
Can you please explain, repeat the question?
If B increased by 10%, what happens to A? Just to put a figure to it. If B increased by 10%, what happens to A?
If B increases by 10%.
It will reduce by 10%.
It will reduce by 10%. Reduce by 10%. That will only imply in case we have perfect negative correlation. Well, this 10 is 10. That means that's perfect. But this is not perfect because this is 0.5.
And what if I say if you said if B increases by 10%, A is supposed to decrease by half. Like for example, I can say increases by 10, then by half. So I can give like a figure of 20%.
20%. Yes, another figure you can give. Or someone who has had was up. Is this?
It was my hand.
Oh, it was my or what? Yes. Okay. Or
When B increases by 10%,
10%. Yes. What happens to A? It can decrease by 20% or
increase by 5%.
no, it can't increase.
Or decrease.
Or decrease by 5% is a decrease of 5%. Yes. Okay, so that's how we can interpret that particular the correlation. Okay, between those two stock A and B. Clear? Yes, Joseph.
In the second scenario, is there any difference? Is there any difference between a decrease of 5% and 20%?
Is there a difference?
Yes. Is there a difference between a decrease of 5% and 20% when B increases by
10%? Okay, let me give you an example. If you are going to make an investment, okay, you're going to invest 1 million, and the return will either decrease, but if they decrease by 20%, what's your loss?
200,000.
This is 200,000.
No, 200. Yes, 200,000.
200,000. Then the other decrease is 5%. What's your loss, therefore? 50,000, isn't it?
Yes.
There's a huge difference.
Yes.
Yes, Joseph, what was your question?
Okay, the 20% and the 5%, I don't understand if they relate with the 10% for B.
They do because, okay, here it was 10%, so this is 10%, it can be 10%, you divide by 0.5, and what do you get? 20, isn't it?
That's 20, yes.
or it can be 10% times 0.5, and you get 5%. So you can go either way. Joseph, I don't know, I hope it's clear. Okay, it can either be an increase, a decrease of 20% or a decrease of 5%. Joseph, I hope it's clear.
I'll digest it later. It's not very clear.
It's not too clear.
Yes,
Okay.
I'll digest it later.
Okay, we mark it.
I also have the same question because I don't understand why how 20%, 5% are the same. And also, like I thought if you have 0.5, that means a increase by 0.5 and same case to B. So yeah, I'm not really understanding.
Okay.
Yeah,
okay.
the difference.
Okay. Now let's take the case here of A having a decrease of 20%. Okay, let's take A having a decrease of 20%. What happens the return of Joseph? Let me ask you this, Joseph. If A decreases by 20%, what happens to B?
B should increase by 10%.
Should we increase by 10%? So that's clear.
Yes.
That's clear for you.
That's clear. This one is clear.
Okay. What happens in case B increase by 10%? Okay, now that's the B increase. No, B, let me take an example. Now B increased by 20%. Yes, I can say 20%. What happens to A?
A should reduce by 10%.
A should reduce by 10%, isn't it?
Yes.
It's clear there.
It's clear.
Which means therefore we can say that the return for B, okay, that 1% return for B is like 0.5 return of A, isn't it?
Yes.
Therefore, one return for B, which was 10%, B increased by 10%. What happens to A? 5%, isn't it?
Reduces by
5%.
5%, yeah.
5%. And this way we have these two. It can be 20, it can be 5. It can be 20 here, it can be 5. Do you get it? Look, these are the same. This is 10, this is 10 also. So you can
thanks. I see it now.
You see it now.
I see the relationship with the B now.
Okay. It does not matter how you arrange it more or less. You can start with A, you can start with B. At the end of the day, the -0.5 has to be obeyed. That's the case. And I hope the same applies to Immaculate. I hope you have understood.
Yes, I have. Thank you.
Okay, so that's on how to interpret the coefficient of correlation. Now, if we have to do the same, we determine what is or how does the return of A and the return of B behave in this return of Y and return of Z. From the same example we have just done from the November 2019. What's the coefficient of covariance between the two? Okay, what did I call it? No, this is coefficient of correlation, not covariance. So it's called coefficient of correlation, not covariance. Coefficient of, or correlation coefficient. So correct that in case you're writing down, is the coefficient of correlation. Coefficient of correlation. Because there is about correlation here. It's about correlation. What do you get for the November 2019? That is in case you are asked to get the coefficient of correlation between the term of y and the term of z.
+1.
Yeah, +1.
Yes.
Okay, let's do it together. Now this is y and z. To be equal, therefore, covariance. What was covariance?
0.2.
4.02%. Divide, standard deviation of y was 2.2.
2.42.
Okay, and the standard deviation for z was
1.68.
1.68.
Yeah.
And you get
0.99, which is the same as 1.
so 0.99 or more or less 1. Okay, positive. Okay, which means therefore we can say that the return between y and z, okay, the return are perfect positive correlation. If A increased by 10%, if y increased by 10%, then B increased by 10%. Okay, okay. If y decreased by 2%, then z decreased by 2%. Okay, or called perfect negative correlation. Clear?
Clear.
Okay. The next, the fourth method, we can use the coefficient of variation. Okay, so fifth method, coefficient of variation. Now, this method, okay, what we want to determine is you have two assets, okay, and you want to establish which one should I take, okay? Among these two assets, which one should I take? Generally, if it's called the mean variance rule. Okay, let me can just put it here, okay, before we even discuss the method. The mean variance rule. Let me actually, so that actually from what you've learned. If you have two assets, A and B, okay, A and B, A has a return of, let's say, 10%, B 10%. The standard deviation of A is, let's say, 3%, and for B is 5%. Which one would you invest?
A.
You would invest in A, and that's the first rule, okay? But in case you have two assets that have the same return, have the same expected return, therefore you invest in the one that has the lowest risk. In this case, therefore you invest in A, and that's the first rule, okay? So you can put it down as one of the rules here, okay? Assets that have equal returns, but different risk, So what do the investor do? The investor choose the investment that has the least risk. Okay, that's the first rule. Okay, then in case we have two assets that have the same return, okay, so but different risk, Therefore, as an investor, since you are a rational investor, you're going to be investing in that particular asset that has the lower risk. Okay. Now, I can form the next rule. In case the same example, A, B, the risk standard deviation 10%, 10%. The return is 13%, and this is 15%. Which one do we take? As you can see, they have the same risk, but different return. Which one do you take?
B.
Because you invest in B. Why in B? Why do you choose B?
Personally, I would choose A.
A. Why would you choose A?
Because A has the least risk.
No, let me actually, this is standard deviation.
Okay.
And this is return.
Oh, this is a return, not risk. Okay. Okay.
Yes.
Let me think.
Sharon,
I think on my end, I'll choose B because I'll get the higher returns. And if I check on risk, is the same. So whether I invest, whether I take A or B, I'm going to like have the same risk. But
yes.
Now it determines on which returns I'm going to get. So I'll go for the higher returns.
Go for the higher return. Okay. Yes, that's what I wanted that gentleman to explain. Not where I think he went away. But either way, that is how. That in case you have 22 assets that give the same, they expose you the same risk. Of course, you take the one that can maximize your return. Okay. So you can. There's the next rule. Therefore, an investor will choose an asset that has the higher return. We'll choose among two assets. We'll choose among two assets. Choose. Okay, let me just call to come in more than two. Two assets. The asset should be not an, but the asset. Among assets, the asset that has the higher return for the same level of risk. Okay. Now, assume that we have now two assets, the same A, B. This is the risk, 10% is 12%. Then you have return. For A, this is 15%, and this 17%. Which do you choose?
A.
Why A?
Because the proportion of risk to return is more viable than B, where the proportion of risk to return is less.
How do you get that proportion?
Actually, I'm just comparing the numbers.
Oh, just comparing the numbers, calculations.
Yes.
Okay. Therefore, the next clue, okay, is what we call the use of coefficient of variation. Okay, there is a coefficient of variation, measure of return per risk. Okay, coefficient of variation is called. So the next rule, you can't just compare the numbers. In short, you can't just look at the numbers and make a decision. You need to do the calculation, okay, by computing what we call the coefficient of variation. Okay, so let's do that. Now, coefficient variation, as mentioned, it's a measure, okay, coefficient of variation is a measure of return expected, No, say that way loud. Not return expected is a measure of risk. Is a measure of risk per return expected. In short, how much risk are you going to be exposed to for every unit of return that the particular asset should be providing? Okay. Let me squeeze it. Okay, that's called the coefficient of variation. Okay, how much risk are you going to be exposed to as an investor for every unit of return that a particular asset will be providing, will be giving to the investors? Okay, I'll call the coefficient of variation. And the coefficient of variation, okay, of an asset will be given us. This table must not be the best table to use. Well, this is variation, not covariance. Coefficient of variation. Let me just put the full name so that I don't use a table. Coefficient of variation for a particular asset is going to be equal to the risk will be the standard deviation we divide by the return expected. Let me call the mean return or expected return. We divide by expected return. Therefore, standard deviation, okay, of standard deviation divided by the mean return. Okay, mean return can be mu, or it can be the R bar. Okay, and that's called the coefficient of variation. Okay, it's a measure of how much risk that an investor, for every return that the investor gets, okay, how much risk does that return comes with, okay, or exposes the investor to. Okay, it's called the coefficient of variation. Okay, actually, I think you can write it down. It is the amount. The amount, this should be amount, not amount. It is the amount of risk an investor will be exposed to for every unit of return received. Okay. Clear?
Clear.
Okay. Now going back to the November 2019 question. Okay. In Roman 2, you're being asked to determine the relative risk of Y and Z. In short, you need to get the coefficient of variation of Y and Z, relative risk. Okay. So we can do that together. November 2019, question 3B. Okay. So that's Roman 2. So being asked to get, therefore, we need to get the coefficient of variation of Y and for Z. Okay. What do you get for Y?
0.23.
Okay, so for Y, it will be equal to the risk for Y was 4 point something, 4 point. What was the deviation for Y? 4 point.
Why? The 4 point was the covariance.
That was covariance.
No, 1.67. 1.68.
Michael, we lost you.
Yes,
That's
I
1.68.
was saying
Yes, 1.68.
1.68. Yes.
Yes, the standard
Yeah.
deviation.
1.68. We divide by the mean return. 10.4. The return
Yes.
10.4.
Yeah, that's 10.4, the expected return.
10.4. Okay, and again.
No, it was 8.7.
No, that's for B.
This we went through Y first. Why first?
Yeah, why it's 10.4?
It's 10.4.
So even
2.42.
excuse me, sir, even 1.68 is wrong. It's supposed to be 2.42.
Oh, yeah.
Yes.
2.42.
Yes.
Okay, not 1.68. 2.42. 2.42 divided by the return, which is 10.4. You get 0.
Yes.
23.
0.23. Okay. The Z, the same process, should be the risk for the standard deviation for Z, which is how much?
1.68.
1.68. We divide by the mean return for Z, which was 8.7.
8. Yes.
Okay, and you get 0.49.
19. 19.
19.
Yes.
Okay, 0.19. Okay. Now, which one do you take therefore? Or rather, let's interpret Y. 0.23. What does it mean therefore? That for every 1% return you be receiving from Y, the amount of risk you'll be exposing yourself to will be 0.23%. For Z, and therefore, for every 1% return you'll be receiving, you'll be exposing yourself to 0.19% of risk. Now, which one do you invest as required in number 3? The examiner asks you in number 3, advise the investor on which of the two securities to invest in. Now, which or where do you invest the money? Or where do you put the money? Do you invest in Y or in Z?
Z.
Of course, you can invest in Z. You can invest in Z. Why? Because for the same amount of return, 1%, you can be having a low exposure towards the risk. Okay, because you have 0.19 for Z. For Y, it's higher with 0.23. Clear?
Yes.
Okay. That's for that particular example. That's question 3. You can see okay, 9 marks. Of course, you can see that it can be done within a very short time. Okay, so
on the first example that you asked, you had a figure of, I think, 10 and 12 and 15.
Yeah, we can do it. Okay, sure.
Yeah.
This was 10%, 12%, 15%, 17%. Okay, this was a return. This was risk. This was risk. This was risk, and this was a return. So we can get the coefficient of variation for each one of them. Okay, it will be equal to 10 for A. Sorry, A is down here. So where is it? Yeah, here it is. Okay, so for A, the variation will be equal to risk 10 divided by 15. This is 12 divided by 17. 0.
0.67.
67. 0.6.
0.71.
0.70.
71. Okay. Now, if you invest A or B?
A.
Of course, A. Because you get the same return, 1% unit of return for a lower amount of risk, 0.67 units of risk. Yeah, of course, you invest in A. Okay. Now, let's see if I can be able to get another question from the examiner. Because the examiner normally asks this question frequently, by the way. on how to assess the risk of an asset. Here it is. Okay, here it is. Yeah, so this is November 2018. November 2018. Question 5C. November 2018, question 5C. Okay. Go through it, then we discuss together. You're being asked to get the return of security, standard deviation of security, collision coefficient between the two security, the return in case your portfolio, and the risk of the portfolio. Okay, let's first do the known to the unknown. So you need to get the return for A and the return for B. Okay, very straightforward. Okay, for A, you need to get the return for A. You can begin here. State of the economy, let me just call it probability. Let me just go straight to probability. 0.3, 0.4, 0.3. The return for A, okay, 12, 15, and 10. Okay, therefore, to get the probability, to get the mean return, probability times return, okay, for A, 0.3 times 12, 0.4 times 15, 0.3 times 10, and you get the sum. Or the sum?
$12.6.
And get 12.6 to be the return expected for A. The same process for B, okay? It will be equal to the return for B, 6, 7.5, and 5. Therefore, probability multiply by return for B will be equal to 0.3, that's the probability, times 6, 0.4 times 7.5, 0.3 times 5. You get how much? 6.3?
Yes.
And get 6.3 with the return expected for B. The next will be now to get the standard deviation. Of course, you need first to get the variance before you get the standard deviation. Okay, so begin with A, probability 0.3, 0.4, 0.3, and then we can go straight to. Okay, you don't need to have done this, but either way. So probability return of A, mean return of A squared, therefore to be equal to 0.3. Return of A, log this, if you have a better space, it will be 12 minus the mean return, 12.6 squared, 0.4, the return, 15 minus 12.6, 0.3, return is 10, so 10 minus 12.6 squared. And get the sum. What the sum? We do it for A and for B.
4.44% squared.
4.44% squared. Therefore, standard deviation, that's variance. Therefore, standard deviation is the square root of the variance. Someone confirm the standard deviation?
.12.
So the variance is okay.
Yes.
Okay, so the square root of 4.44, okay, to get 2.21% to be the standard deviation for A. For B, the same process, but you do for B now. Okay, for B, okay, we've done the same process. Standard deviation, no variance, 1.11. variance.
Yes. Yes. Yes.
1.11 to be the variance.
Yes.
Okay. Therefore, standard deviation is the square root of the variance. And you get how much? 1.05% 1.05% with standard deviation for B. Okay. Next, we are being asked to get the correlation coefficient between the two securities. Okay, between A and B. Okay, the coefficient of correlation between A and B. Of course, therefore, we need to get the covariance. Okay, don't forget you need to get the covariance between the two stock. Okay, so therefore, the next process is to get the covariance between a return of A and return of B. Okay, therefore, if you have enough space, don't forget to just continue. Actually, I think I can continue from here because I have space here to be enough. With the probability, okay, probability of return of A minus the mean return for A, return of B, mean return for B. Probability is 0.3. The return of A is 12. So 12 minus the mean. 12 minus the mean was 12.6. The return of B is here, 6 minus the mean return, 6.3. I don't have space myself. 0.4, return of A was 15. So 15 minus the mean return, 12.6. Return of B, 7.5 minus 6.3. 0.3, return of A is 10. 10 minus the mean return, 12.6. Return is 5 minus mean return, 6.3. And you get the sum. That'll give the covariance between A and B. Covariance between A and B. You get a math? .22
Yes.
percent squared. Someone to confirm? 2.22% is squared.